Okay, so welcome again to another Cello All-Core Dev Call. This is All-Core Dev Call 9, and we have a very packed agenda for today. So in this call, we're going to cover first the Geth vulnerability from 2 days ago. Then we're going to cover 2 CIPs by Victor, CIP 39 for mnemonic phrases with error correcting code, and then CIP 40 for extension of Otis. And then CIP 43, 47, 45, and 48 are going to be included in the e-hard fork specification. We're going to go over those, then we're going to talk about the final e-hard fork spec, and hopefully we're going to submit it for last call. So yeah, with that, let's cover the Geth vulnerability. Or you want to kick it off?
Sure. So yeah, the Go Ethereum team released a security patch version on Tuesday, which they announced, I think, the week before, maybe even earlier. And because Cello blockchain is a fork of Ethereum, then we were concerned that maybe it would be affecting us as well. So when they released the patch, we looked at what the changes were to identify what the vulnerability was that they actually fixed, because they didn't make that public. And so we figured out what the vulnerability was. We figured out that we also have it, but that it's something that you can only really trigger with very specially crafted assembly, Ethereum assembly code. So it doesn't really affect any normal contracts that were not specifically crafted to do that. And the effect, if you have a contract that is crafted to do that, the effect is it would give an incorrect result. So it's kind of like the contract being buggy in a way. And so based on that, and because on Ethereum, if something like this happened, it could trigger a chain split, or it could cause nodes to not be able to sync anymore. On Ethereum, sorry, on Cello, because we only have one implementation, they will all agree on the result, which in this case would be an incorrect result, but they still don't agree, so the chain would still go on. What this means, though, is that fixing it requires a hard fork, because if you fix it on like half the validators and half the validators don't have the fixed version, then the chain could stall. And so fixing it requires a hard fork, but because it's something that's not going to affect normal contracts in any way, we decided that it's not really necessary to do an emergency hard fork. This is something we learned, I think, last year when we did the Chorito fork. We realized afterwards that it doesn't actually need to be separate, and we just folded it into a donut for main and alpha horse. And so the idea here is to do the same, to just include the fix and activate it in the next hard fork, which we're planning.
Cool. Yeah, so we're going to include this, like the patch in the e-hard fork. And does anyone have any questions specifically on the Geth vulnerability? Going once, going twice. Okay. Speak now, forever hold your peace. Okay. So now let's go to CIP 39. Victor authored this. Victor, you want to cover this?
Yeah, for sure. So the high level idea is this is a proposal to like extend BIP 39 such that it includes error correction, and a certain number of words can either be missing or malformed, and have it still recover the same key. One thing that I want to note right away is that it actually is like a CIP39 phrase is a BIP39 phrase, and that all the differences are internal, such that it essentially just means, one second. Oh. Sorry about that. Essentially just means that you have the error correction without actually having apps that don't support it notice anything different. And so basically the way this works is it replaces a certain amount of the random entropy that is encoded in the BIP39 phrase with error correction codes, specifically Reed-Solomon codes, and will allow a configurable number of words to be corrected, either unknown words, as in a word that is mangled but actually happens to be a correct BIP39 word. So going from something like, I believe like, if it went from like tent to rent, which actually both happen to be BIP39 words, and are one character apart, that would be undetectable, like as far as like you wouldn't know there's an incorrect word. But as long as only one of those happens, if you have 3 error correcting words, it would automatically fix that one mistake. Then also, if you have words that are mangled such that they are not valid words, for example, like going from rent to like rant or something, then it would basically you would be able to detect the fact that rant is not a valid word, and that is what's known as an erasure, or basically it's a detectable error. And so you could correct up to 3 words that are known to be incorrect with a 15-12, like a 15-word phrase that has 3 of those words being error correcting. For more parameter choices are kind of in the chart below. And then the rest of the proposal kind of discusses things like how to interoperate between BIP39 and SIP39, including a discussion about automatically detecting BIP39 phrases in a SIP39 application, such that basically not only like it is both true that a BIP39 application will accept a SIP39 phrase, and that a SIP39 application will accept a BIP39 phrase. That's basically the bulk of the proposal it talks about. And so, you might ask like what is the upside in all this? Basically, essentially is that it covers the case where someone wrote down their phrase wrong or entered their phrase wrong, or like some words are missing from their backup. I think there's an interesting discussion there about how many use cases that Timeout actually covers. I think it's probably truly the case. It probably is the case that saves some users, but not a huge number. Although I definitely think that this is kind of an interesting application at the very least.
So it improved the user experience in a way. It does improve the user experience when you want to type in your recovery phrase for a BIP 39 kind of specification, right?
That's right. I should note that there are other strategies for handling this. In fact, actually in Vora, I recently implemented a version of spelling correction based corrections, and it works basically in as far as like accidental user errors like typos. It covers that case quite well. And so I would say that this system is stronger under cases where there's actually lost information, where basically you actually are missing a word, or you have a word that's completely wrong but is still spelled is going from tent to rent, where it's like still valid word, but it's in the BIP39, but it is incorrect. This covers that case better, but it's not the only solution to this issue, essentially.
Cool. And I noticed this is a rank 3 because it doesn't really impact like core, but it's something that is definitely an improvement on the existing standard and stuff. Do you have a timeline on this, or is it like you're looking for feedback on the design and stuff, or?
Yeah, so I'm definitely looking for feedback on this design. I think I hope that I think it's a rather interesting proposal. I think I'm rather fond of it, especially from a technical perspective. I think I'd love to basically have people poke holes in it, or I say just talk about whether or not it's what they think about it. I also have not pursued implementation yet, because I think that basically, as mentioned before, I think the number of users it actually kind of saves is unfortunately not that many. And so if other people kind of think it's it fits their needs well, then they may want to implement it. And I'm definitely interested in implementing it from a kind of an interesting tool. However, I think that I've not prioritized working on this. I'm working on implementation right away.
Okay, cool. Yeah, anyone have a question?
Yeah, I have a question. You sort of just alluded to this a moment ago, but it was kind of 2 questions. One is a prioritization question, and it's about how does this fit into the more long-term vision for like a passwordless Valora? Would you see this as like a nice to have in the interim, or something that would continue to have value past that, past any major changes Valora might make? And then the second question is more of an implementation side thing of just like, if we do build this, and I think it would be great, by the way, I'm in favor of this. I'd love to see it done in a way that it's kind of like well isolated or removed from the kit. It could be part of the kit, but I'm thinking selfishly, I'd love to include such a thing like this in Celo Wallet, and I don't want to bring the entire utils package along with it if I were to do so.
Yeah, it definitely could be implemented as a library on top of existing read Solomon code libraries which exist out there, and existing like BIP39 libraries which also exist. So basically, if it would, in fact, I actually wrote a Python implementation of this idea, which is linked below, just a proof of concept. And in total, the Python implementation is like all of 100 lines once you import BIP39 and read Solomon coding libraries, which also exists for JavaScript, for instance. And so I think it's very possible to create a small library that implements this proposal without huge amounts of code bloat. At least as far as like 99 lines, nice. Including comments, yeah. Yeah, so I mean, the basic idea itself is rather simple once you get down to it. Like, it's not a super complicated proposal. There are some caveats, I must say, like, it needs to actually be a little bit refactored as far as the exact encoding format it uses, but the core idea is there and it does work.
How about the prioritization question in terms of like, do you think this is, it sounds like you're saying because it's relatively simple, it is worth the work to do this now, even if we maybe don't see seed phrases being a crucial part of key management in Valora going forward. Do you agree with that?
Yeah, I think the reason I have not worked on implementation within Valora as part of like my, my day job, like I implemented the Python script as a fun thing on weekend one time, is because there's been hesitancy around changing the seed phrase at all. And so I wanted to move on to talking about cloud backup, which the next proposal actually is related to. And so I just haven't taken the time to go back to this proposal again. I still think it would have some improvement, but I think that given like just for the sake of focus, I haven't pursued this one further recently, implementation-wise for Valora. If someone else is interested in it, that would definitely spur me to kind of like to make sure it actually gets into production, or gets like a library is out there that is production ready.
Yeah, so two thoughts here. For implementation, we can scope out a bounty or something if we can outsource it to some like team that wants to work on this as potentially. So obviously maybe something that you'd want to review as well to make sure that they're not doing anything different than what the specification implies. And the other thing I'm thinking is, in the existence of an implementation that is production ready, I would highly encourage you to as well make an EIP out of this and submit it to Ethereum as well, and show them that there's something that we've worked at Celo as well, because I think it can like apply to Ethereum, and I believe BIP Bitcoin as well, right?
Yeah, I mean it's generalized across any network that basically anyone can use this proposal. Mm-hmm.
Or you had a question?
Yeah, it's really more a comment, and it's not really about the proposal so much as about wallets that would use it. So I think there's only one hardware wallet that has support for Celo, which is Ledger. And Ledger, unfortunately, doesn't support 15-word mnemonics. I wish they did. So what I would say is, first of all, if somebody wants to integrate this into wallet, maybe they should go for 18. Even though I hate long seed phrases, like I like 12 best. But just from the point of view of Ledger compatibility, I think 18 would be preferable to 15. And maybe it should be included in the CIP as just like a friendly suggestion to recommend like certain values with NK as like reasonable defaults for developers to adopt, and N should be 18 in that case. And I think, can you scroll down to the table, Yaz? Yeah, so I think there's never any need for more than 120 bits of entropy. So I think 1812 would be probably the default that I would choose. to recommend to people.
Yeah, that's actually hits on a question which is a little bit interesting in this proposal, which is that because there are multiple offered mixtures that of a certain phrase length, so basically that you can do an 1812 or an 1815 phrase, it makes it hard to distinguish the two. It's possible just by trying both, and this is a huge risk, but definitely would simplify the proposal to make it so that it only supports 12 words of entropy, so 128 bits. And I also agree that I don't think it reduces security either. And that's
I would definitely be in favor of that. I've never liked seed phrases with more than 128 bits. But yeah. I know that people use them, and in fact, like Ledger and Trezor by default give you 24 words. I think that's unnecessary and doesn't really help. So I would favor that idea, but I don't know if, maybe I'm missing something.
Yeah, I just need to interject just for, for time. I like where this discussion is going. I would encourage you all to take it to the issue ticket for just in the interest, because we have a packed agenda, but I love it so far. I really like the proposal. And let's move to the next topic, which is also by Victor. CIP, what was it?
40. Yeah.
Yeah, let me find the agenda. Hang on. Oh, there it is. Okay. CIP 40, extension to Otis. Whoa, what did I do? Yeah. Okay. You want to cover it, Victor?
Yeah, 1 second. All right. So the high-level summary of this is basically we have Otis, our privacy preserving phone number hashing service, to allow for the identity mechanism to work without allowing people to discover someone's phone number from their account address. And we would like to extend this service to also be useful for hardening passwords. So the core functionality was called an oblivious pseudorandom function can basically be extended such that it also works for passwords hashing, and actually quite a few other use cases such as private set intersection or other applications in the literature. Just for this proposal, I'm focusing on password hashing because that's what we immediately want to use it for. And so the high level idea here is that basically subsequent following a change to the cryptography to allow for a public input as well as a private input to the Otis function. So right now the phone number is the private input. Otis does not see the phone number, but it basically hashes it for you without seeing it. This basically allow you to have the private input, which basically would be your phone number, or in this case, a password, and also a public input, which basically says, this is the rate limit on which you should apply to this password when you're hashing it. And basically this public input basically could be thought of as like a salt essentially, but with a little more flexibility I'll describe in a moment. And this salt uniquely identifies the account or the context in which this password or other secret is being hashed. And the context basically sets a rate limit. So basically, if I am hashing my PIN code, 6-digit PIN, I want extremely low rate limit. So like 10 absolute tries. After 10 tries, to not allow any more queries against that particular salt. That way people cannot continue to try to guess the password or guess the PIN code. If it's more like a password, something that has a higher entropy value or a phone number, then you might have a higher rate limit. For example, you could have like 10 tries per week or something, or have a exponential backoff function. So basically, there are a number of contexts you could use this in, and each context should have its own rate limit. And the domain specifier, which is this public input, and allows you to specify that rate limit and the context under which this password or other secret is being hashed. The application that we are working towards with this is a cloud backup system that uses the user's PIN code to encrypt a backup of their account key and store it in their cloud account. And in order to do this, you need to enforce a rate limit per PIN code, among other things, as context. Now, as far as the exact specification, this proposal mostly gets into basically the API specification. So it talks about how to actually interact with this service. And the majority of the proposal discusses different domains. So as I mentioned before, the domain includes information about the context and also about the rate limit itself. So basically the context is something like, this is a password, and with this particular identifier or salt value, and the rate limit can be specified as the user can actually say to the service, I want at most 20 queries against this password to be available, or I want at most 10 queries to be available with this password. And the user can actually choose that value and have it reliably be enforced by the service. And the way this essentially works is that basically the entirety of this domain value. So if you scroll down, let's the example section, this might be a bit easier as well. So a little bit further. Let's go a little further down. So let's see, yeah, like this linear backoff domain. So basically what the user would say is they can specify all these values. They can say, this is a linear backoff domain, meaning that it has a certain linear refresh rate, or every X seconds you get a new quota. And you specify the refresh time, and then also the cap amount of saved quota and the salt. So basically the salt is the context that uniquely identifies the instance of this domain. And then the refresh and the cap are both rate limit parameters set by the user and enforced by the server. And basically anyone who changes those parameters will get entirely different outputs. So basically, if I'm an attacker and I think to myself like, oh, like I'm out of quota, but I'm just going to raise this cap, it becomes useless to you, because if you submit that domain to the server, the output will be completely different than the output that the user would get when they use the correct rate limit parameters, which is pretty interesting. I also provide a number of other examples here as well. So beyond just password hashing, or beyond just like a salted hash, you can also do something I've not before, where I see the service only answers queries after a certain time. You can do authenticated requests that basically require you to submit a signature against a pre-committed public key. You could do the current phone number hashing system. And there's also a specification or an example here for smart contract controlled hashing rate limits. And all these examples are meant primarily for instructive purposes. None of these examples themselves are standardized, but the idea is that basically gives you a broad amount of flexibility to implement, to use this hashing service as a core primitive in privacy preserving protocols, which is something that a lot of applications I think can benefit from. And the rest of this proposal kind of gets into various other pieces, including how you check a quota status, the ability to like disable or burn all quota in a domain, and some detailed discussion about how you actually hash domains such that you can guarantee that they are unique and deterministically mapped to a particular rate limiting structure.
Okay, and this concerns mostly Otis, right? So Victor, maybe it would help to, like, if we can frame this from the point of view of Valora, like what kind of improvement, like I guess from Valora, if I'm a user on Valora, what would this kind of proposal improve for my experience per se, let's say?
Yeah, and so the way it's going to be visible in Valora is it's going to enable what we are calling it's cloud backup, basically. So cloud backup of your account. So what the user's going to see once we enable this feature is just they log into their account, and like when they're first onboarding, they enter their PIN code, and then basically just be asked like, hey, do you want to enroll in cloud backup? If they say yes, then basically it will send their PIN code to Otis, blinded, so Otis will never see their actual PIN code, to receive a hash of it through this service under a very strict rate limiting regime. And then it uses that hash as a key to then encrypt the user's account key and store the encrypted ciphertext in their cloud account, so either iCloud or Google Drive. From that point forward, if they ever lose their phone or lose their account, and they open up and they try to restore their account on a new device, then what they can do is they can say restore account, restore from cloud backup, and if they log into the same cloud account as before, so either their Apple account or the Google account, they can download the ciphertext then they can enter their old PIN code. It will be sent off to Otis hashed. They'll get the hash back. And if they entered the correct PIN code, then it will derive the same encryption key as they used before, and they can then decrypt the account key and reinstantiate the account. And one thing I want to mention here is that this proposal is also something that we would love feedback on, and I can link more detail and give a chance for people to give feedback on that as well. But that's the current plan for how this will affect the Valor user experience.
Well, that's amazing, because basically, let's say I lose my 24-word phrase and I lose my phone and all of that, but I know the ciphertext on Google Drive. I can just link to that, and I know my PIN number, which is like, I guess, 428 PIN number, right? I can just put that in and recover my account, so that way I can get back access to my Valora wallet and stuff, without, even if I lost, hypothetically, my account, my seed.
That's right.
That's amazing. So I want to be conscious on time, but let's give folks who have any question to ask the question. Otherwise, let's move it to the discussion item. But does anyone have any questions on this?
Just one, maybe this is a silly question. I'm not sure. When you change your PIN, like the rate limit, can the rate limit limit how many times you can change your PIN, or is not related?
Not as designed, because there's no concept of like the user itself. Basically, they would just changing your PIN would just involve creating a new domain, which is free and cheap. And basically you just would create, and that would basically derive an unrelated new new encryption key, and therefore you basically create a new backup ciphertext.
I see. And the domain is stored in the cloud as well?
Yeah, basically you store, the main thing is you need to store the salt value as well as the rate limiting parameters. But yeah, you store the domain along as metadata to your ciphertext. That way you know what to send to Otis.
Cool. Any other questions? I would invite everyone to continue the discussion on the issue ticket here. I linked it in the chat. But this is really cool. I mean, it's in a way one step closer to social account recovery, right?
Yeah, which we also are intend to pursue social account recovery as well in the future. But I think this is a kind of a complementary proposal. It has a lot of nice features that I think as far as ease of use and quick recovery times, that social account recovery won't be able to provide. Yeah,
and it does make it much better user experience for people who are not necessarily crypto savvy to just remember a PIN code rather than the 24-word phrase. But yeah, this is awesome. Okay, next up we have Joshua to cover the final. We have a bunch of CIP that's going to be added to eHard fork, starting with CIP 43 block context.
Yep. Am I coming through?
Yeah, you're perfect.
Cool. So the block context is kind of a shorthand name, but what it focuses on doing is calling some contract calls that are used to verify the validity of the transaction. So when you do something like get the gas price minimum, under the hood, it actually does a currency conversion. So if you have an Oracle update, so the current thing now is we call gas price minimum and verify that for every single transaction inside the block. And now if you have an Oracle update transaction in there, you can actually change the gas price minimum. So as it's specified, you have to call it every single time. And so the goal of this CIP is to be able to only call the gas price minimum contract call once at the start of the block, essentially. So it refers to the previous block state, and that way you can use the value over the entire block. And so that gives you a constant speed up factor on every transaction. And that's something that goes towards the long-term scalability goals of the Cell blockchain client. And so there's a couple other calls that are specified around how we, for what I think transfer whitelist is not in there, but is frozen. So these are ways that the Celo blockchain client interacts with the core contract. So it's kind of what's specified here.
Awesome. So yeah, I mean, like the TLDR is by calling the get gas price minimum at the start of a block from the previous state, that result in better, higher improvement in scalability, like long-term scalability and calculation and stuff, right?
Yeah.
Awesome.
Do less work.
Less work.
You're also like the Tobin tax call.
Tobin tax portions of that would have to be called for every transaction, but if it does a currency conversion in there, that would be done with the rate at the start of the block. So you'd only have to do the currency conversion once.
I see. I guess it's not clear to me why it would have to be in every transaction. We can talk about it later.
Okay. Does anyone have any questions about block context? I'm just going to add the discussion here. But yeah, this is one that we're want to add to the eHeart fork that has not been named yet. But yeah, let's move on then to the next item. But like the issue ticket is here. Okay, CIP 47 increase round chain timeout formula modification for IBFT. Oh boy.
Yeah, so this is a pretty technical topic. The summary is that when validators are proposing blocks, and if they don't see a block, they wait a certain amount of time before moving on to the next validator to propose kind of the next block at that block number. So there's kind of switching through all the validators as bumping up the round, and then kind of there's a sequence number which corresponds to the block number. So if there's a couple validators offline, or if there's bad network connections, you could go through multiple validators and validate a block in a later round. So what this is doing is making a slight modification to how you calculate how long validators should wait before moving on to the next round. And the reason for doing this is the old formula, the timeout for the first and second rounds was actually shorter than the timeout for the 0th round. And we'd kind of like to correct that because if you have something that causes a timeout in the first round, it's pretty unlikely that it'll be resolved until you have a longer timeout. And that's basically what we're doing with this new formula. So instead of like 5 seconds for the first round timeout, it would be 10 seconds. And you can see this kind of formula. As you get into larger rounds, the exponential behavior starts to dominate. And that's actually the reason you have exponential behavior. Digging into the weeds a little bit is because that's part of what makes this work in an unsynchronized network where you can't synchronize clocks, which is a pretty standard assumption for distributed systems.
Okay. And from what I'm noticing, and this is just me curious, like it showed like marginal increase in seconds from the old to the new, right?
Yeah, so this tweak is really about the early rounds. So we're adding only a constant amount of seconds, 5, and then it very quickly gets dominated by the exponential behavior, which we're going to keep the same.
Okay. So this is like a consensus topic. Does anyone have any questions on this?
Yeah, is the round timeout calculated from the previous block's timestamp?
In terms of when you actually start doing the timeout, I'm not sure. It would typically be once you start the new sequence. So in that case, it'd probably be once you finalize the previous block.
Interesting.
Any more questions? Okay. Tom, do you have a question?
Oh, I'm just going to present the next one.
I didn't want to put you on a spot because you turned on your camera, my bad. Okay, let's see. Moving on to CIP 45, relax, modify transaction fee check. Tom, you want to kick it off?
Yeah, so this is a pretty small one. So for now, the behavior of paying transaction fees using non-native tokens, we require the balance to be strictly greater than the required fee, which doesn't make sense. So this is not consistent with our how we pay fee in the native token silo. So we just change this behavior to like the two behavior to be same, which is like if you have greater than or equal to the required fee, it should be fine. And that's it.
Okay, so right, it's a really simple change. Greater than equal to rather than just greater than.
Yes, yes.
Yeah, okay. Does anyone have questions about this? No, I think it's really straightforward as a modification. Okay, so CIP 48, the last one before we talk about the eHard fork. Modification to gas repricing for Cello. Joshua, you want to kick it off?
Yep. So some of the gas pricings in Cello are not quite the same as in Ethereum, and the biggest changes around this were the cost of the S loads and not the calls, but the X hashes, and then I think balance as well. So basically, we adopted part of EIP 1884, which was the first kind of big repricing. There was repricings in like Tangerine Whistle, but that was the Istanbul repricing. And so as we're kind of moving into Berlin and London, we're basically going to be taking the prices from the Istanbul and then using them for 29.29. And the reason for this is our state is smaller than Ethereum, so these operations do take less time. So we're kind of lagging behind Ethereum there, and we're fine with that. But we do want to make sure that as the state grows, we're signaling that, like Ethereum, we will be increasing the gas prices.
Okay, so this is the gas pricing changes, and it will bring us closer to upstream, basically, like
yeah,
up to London as well, right?
Yeah, and so this also includes the new formula around access lists. So here, the cold desload cost, that's 800. That's what that's from 1884. In 29.29, it's 2100. Yeah, 2100, I believe, and that will kind of move towards 2100 in the future. The warm storage cost is the same at 100, and then the cold account access cost is 900 versus 2600 in Ethereum.
Alrighty. Okay. So, does anyone have a question about the gas repricing or including the gas cost? Okay. So let's go over the CIP 41, which is the eHard fork meta CIP specification. Let's see. Yeah, so these were already covered, and we covered CIP 48 today, and these were going to be included. And then we had from 2 weeks ago CIP 42 modified EIP 1559. So I think like, and everyone else feel free to add on top of it, but CIP 41, which is the eHard fork, that yet to be named eHard fork, is basically we're gonna bridge the gap between us and get upstream, and at the same time include a lot from London and Berlin hard forks in Ethereum, as well as, we covered things that are improvement to the block context, increased round chain timer for the early rounds in IBFT, and relaxing the can pay fee, and modification to EIP 2929. The other thing is we're not including the difficulty bomb delay because I don't even know why they had it in the beginning, but like, I mean, at least for us, like we're not a proof of work network, so we don't need a difficulty bomb changes because we don't even have a difficulty bomb in our protocol. Let's see. And then finally, CIP 42 modification to EIP 1559. Okay. So is there any question about this specification so far for the eHard fork and stuff? Anyone had any question about eHard fork and what's going on into it? Because this is the final specification that we're proposing from the CLAC team, and I want to bring the question to the community on any feedback on the specification per se.
It's not specifically about the eHard fork, but about some of the gas related and gas estimation related changes we're bringing in from upstream. Do we have summarized somewhere like a nice list of where we match 1559 and where we will continue to differ after the eHard fork?
I think Or has a good breakdown of some of it. Correct me if I'm wrong, or you had a Notion page or something about 1559, and or was that related?
Well, there's, sorry, are we talking about the specification or the parameters?
The params, I think. Like the gas prices, right, Rossi?
Yeah, I'm talking about basically the specification.
Yeah,
Like
so
maybe-
the best bet there is CIP 42. The TLDR is that we'll be continuing to calculate the base fee, also known as the gas price minimum, kind of Celo terminology, the same way we have been, but then we'll adopt type 2 transactions from Ethereum, as well as kind of Celo specific version of type 2 transactions. And those will basically follow the same thing of upstream. So from an end user perspective, there might be a couple RPC changes, but the user perspective will be very similar.
Yeah, so just to fill in on what Yaz mentioned, so the Notion page that I wrote up was not about that. It was about the choice of parameters, or like the adjustment speed and the target density. And we expect to post a forum post on that topic in the future. But it's kind of orthogonal to the actual specification.
Does that answer your question, Rossi?
Yeah, mostly. I think I'll need to dig a little deeper, probably into SIP 42 details. That's probably where I'll find more answers. Quick question for Or then. Do you foresee any of those parameter changes you're exploring making it into the eHard fork, or you think that's probably to continue explore for down the road?
They're not hard fork changes, they're governance. So essentially you're changing the parameters on a contract. You're not actually modifying the contract. So just a governance proposal.
Got it. Cool, thank you.
Any more questions about eHard fork? If there's no question about the specification, maybe we can talk a little bit briefly about what we think the timeline might be. Does anyone want to take up that?
Sure. So from kind of C-Lab's perspective, we're working on bringing in a lot of these upstream changes. And so we're making a lot of progress there, but integrating them definitely is a big task. So we're kind of don't have a finalized date, but kind of expecting somewhere in the range of end of this year, start of next year for the hard fork. And then kind of we're hoping to make that a little more certain in the next weeks or month.
Sorry, let me just mention one more thing related to the previous question from Rossi. So these parameters in Ethereum, they're hard coded, so there it would be a hard fork. But for us, they're parameters in the contract, just a governance proposal to change it.
Marcelo is great.
Okay, the other question I had, maybe like that would help some people, is do we have an estimated timeline on testnet hard fork? Maybe like I think like maybe it'll be in the next few months or stuff. Would that be an accurate estimate?
Yep. We'll give validators at least a month, probably a little bit more to upgrade before mainnet release, and so then working backwards for there. From there, the main testnet release would be 3 to 4 weeks before that. So kind of 2 months before the hard fork date is when the testnets will go live. Public testnets will go live.
Great. Alrighty. So finally, I'm gonna move this. I want to move this from draft to the review stage, just for people to have like extra time to review all the changes and stuff. But given this is not very controversial changes, this is just like bridging the gap with upstream. I don't think we need that much of a review time and stuff. But so that everyone, I want to check for rough consensus that everyone is okay with us moving this to last call for like a week from now. That way we'll give everyone a review, and then after that, it becomes an accepted standard, and that freezes the specification, so we don't need to add new things to it after and stuff. Is everyone okay with us moving this to the last call? Okay, I got a thumbs up from Rossi and stuff. I guess the best thing to ask is who's not okay with this. And I'm getting silence, so I'm guessing everyone is good to go with this. Okay, cool. So here's what I'm gonna do. I'm gonna, like, my action item is moving the specification itself and all the other specs, like all the meta specs within it, to last call. But like, yeah, that'll be like 1 week review, like, so people can get feedback on the specs, and after that, it's all about implementation. Okay. Since there's nothing else on the agenda, I think this is great. We finalized the eHard fork, at least moving it to the review stage. And I'm gonna stop sharing my screen. And yeah, I think like we're one step closer to a new hard fork. So woohoo! And yeah, I want to thank everyone for taking the time to attend the All-Core Dev call. I think we covered a lot here, and it's a lot of new exciting changes coming to Stellar. And with that, I want to thank you all, and I'm going to start stopping recording.